Hello, my name is Shen Wang. I'll be presenting to you about Assurance IQ's case study, Unlocking More Business Value with Starburst and Tableau. I'm the principal data engineer here at Assurance, and let's get started. So, how do we accelerate our time to insight, improve our customer conversion rates, and enable robust modeling for insurance recommendations? Or basically, how we achieve better business outcomes with Starburst and Tableau together. A little bit about me. I'm Canadian in Toronto. I started my career in advertising technology, and I've been at Assurance for 3 years, and I'm the principal data engineer now. What does Assurance do? Why is this relevant? Assurance is an online insurance distribution platform for financial products and insurance, as you can see here. We really connect the customers, the agents, and the financial products together. We have hundreds of thousands of different products that exist, and lots of, there's a lot of industry jargon, terminology, rules, regulation, fine print through the purchasing process. And if you've ever tried to purchase insurance in the US, you know how complex this can be, depending on what state you are in, what zip, what county. A lot of other factors are involved in this decision. And so we are here to make it radically easy for customers to navigate this complex world of financial products so that they can really find the right type of coverage and products for their needs today and into the future. And how do we do this? How do we do all this? We do it with data, of course. Right? Data is a core part of what we do. We really leverage data science to optimize this marketplace. And here are some example recommendations we have throughout the customer buying journey. As we progress through each step of this buying journey, we run models. And we run models for such things as product recommendation that draws on multiple data points from form responses from the customer to how they engage with the platform, customers' data from third parties, or details of our insurance policies and how they match with the customer. The list goes on, on, on. And this data can be from multiple different domains and microservices, from things such as our website clickstream information, to our agents and license information, to our dialing and how often we've called them or what interactions we've had with the customer before. We can do all of this with our data, and all these amazing things with our data, but this was not always possible. We could not just get data across domains. Before Starburst, we really struggled to join one database to another, right? We would need a data engineer to make a copy of the data manually, right? Add some cadences, to do very basic stuff such as just running a dashboard on it. And for complex things like building and analyzing our models, this could really take a very long time. And it could take a very long time for even simple things. And this is a big problem, is we cannot scale to the needs of our business. As our business kept growing, our lines of insurance and businesses kept growing, all the different teams and lines of businesses will be fighting to be on top of the data engineering backlog so that they can get their analytics first. And really, this hamstrung our time to insight for all of our businesses. And it was taking weeks to deploy data that we needed to manage and operationalize each of these businesses. The data scientists were underutilized at this time because they would have to go, oh, we need to get this new data in before we can actually start work. Stakeholders don't know what is going on and how long something might take, because there's multiple different stakeholders all trying to get on top of the priority queue. And the business is completely on fire in the background, right? We cannot get the data to analyze, to really operationalize our business. And this is where Starburst really comes in, and Tableau as well, right? It's really hard to believe we existed in a world before this single point of access is not the norm, right? This single point of access has really unlocked a ton of business app value that allowed all of our dashboards and things running off of Tableau to function. And we'll dive into this today. So I'm going to narrow down this context. We deal with a lot of lines of businesses. I'm going to focus on a specific line of business, Medicare. Okay? And really deep dive into how Starburst impacted this line of business and how it improved our time to insight in multiple business problems. What is Medicare? Really, Medicare is the United States government's federal health insurance program. It is for people older than 65 years of age, or if you're younger and have a disability of some kind. It allows people to enroll into the program and have the government cover their medical expenses. This is a really big and complex job for the government to run, especially with all the different hospital networks, et cetera, throughout the United States. So they partner with private companies through the Medicare Advantage program for consumers to pick their own plans, evaluate what is out there and pick the plans that meets their own needs. The insurance carriers get that more economy of scale for these types of plans, and the consumers get more coverage based on their needs or in the areas that they care about. This is really a win-win for everyone and really super important. But there's some problems here, right? You can tell like there can be a lot of plans. Not just that, there is a single period of the year. It's called the Medicare annual enrollment period or annual election period. AEP, we'll be saying that multiple times. This period is where the majority of all enrollments can actually happen legally. Right? This is only a 7-week long period. This is when you're eligible to enroll in new plans or change your existing plans with the carriers without some kind of penalty. And Medicare, as we were talking, is really complex, right? It's incredibly complex. We've got things such as different eligibility factors, like your medical history, your state, zip, and county, where your doctor is located, what drugs you take, and all that stuff. These can lead into eligibility factors of what policies and plans can you actually enroll in. Right. And we've got hundreds of carriers and multiple different types of plans, such as HMO, PPO, PFFS, et cetera, et cetera, et cetera. Like, I can't imagine my grandparents actually navigating through all of this. It's daunting, right? So shoppers really want help in navigating through this. And what that means is our shopper volumes explode during the 7-week period. AP period is it's the biggest business driver among our Medicare line of business. And we prepare for this throughout the entire year. It's like preparing for the Super Bowl, right? All the work throughout the entire year is for this set period of time. So our first business case is, how do we leverage this Starburst and Tableau to really prepare for this launch, right? How we optimized our agent licensure strategy. What does this mean? One of the key conditions with agent licensure is that in order to enroll a shopper in the Medicare plan from one of our marketplace partners, one of our carriers, our agents must be licensed by the state the shopper resides in and appointed by at least one carrier in that state, so that they can sell that policy. But this costs money. And so how many state license and carrier appointments should we buy for each agent to maximize our profit over the annual election period? So one of our smart data scientists really came up with a brilliant solution. Use mixed integer optimization model. Right? This really allows us to define the constraints in our platform, feed in the data, and iterate over multiple scenarios, and then output some scenarios to then be analyzed and see if that is the optimal solution. And so these are some considerations he had throughout this entire time. State licensures and carrier appointments are not free. They cost time for us our business teams to help the agents get them and get licensed in them, and they cost money to actually be appointed in them. Agents have varying levels of skill. Like, how do we simulate different agents at different skill levels? Agents work at different times. We're like, fully virtual. All of our agents work from home in a sense, or wherever they feel comfortable. So different agents log in at different times and log out at different times. It's an on-demand workforce. So we can't control that as well. So how do we simulate when do people go on and work and are able to take these calls? And our shopper volume and state mix can vary seasonally or for other different factors. By hour of days, day of week, it can vary by, like, say, an ad was placed, a TV ad was placed, and we all of a sudden see a spike in this state. It can vary drastically. So we need to simulate that as well by geography, because, as I mentioned, this agent is appointed to sell for a customer in this state. And so if all of a sudden, let's just say, a lot of customers from Texas come on and want a plan, then if we don't have enough agents appointed to there, they cannot help them. And we're potentially losing a lot of the revenue. So in the perfect world, we can just go, hey, select star from some clean and ideal, pristine table. But that's not really how the real world works, right? Data is generated from multiple different processes, from multiple different systems, and different teams own that data in these different systems as well. It's hard to grab them all together. So this data is living in multiple different Postgres systems. It can be living in S3. It can be living in, like, people's local computers as the cost or the forecasts, etc., on their Excel spreadsheets and stuff like that. And we need to aggregate all of this information, coordinate across multiple teams to get all this data together. And with Starburst, what really allowed us to do is the data science doesn't need to worry about this. They can focus on the right side of the equation, the Tableau, the dashboards, the optimization of the models, and bringing data into the data lake is simple, and querying it is very simple, all with Starburst. So we were able to complete this project of really optimizing our agent licensures within 2 weeks instead of potentially months of work. Being able to get a jump on the licensing process itself meant more licenses, as it takes time to process people and get these licenses. And being able to identify these optimizations led to a huge reduction in cost, estimated 40% on a multi-million-dollar cost line. And also it increases conversion rates, as we are able to service more customers in more states at the time that they need help. And this in turn increases our revenue overall. Now, we've done the plan, we've got all the agents, they're all on the phones, right? They're ready for AEP. And then everyone's ready to go. Day one of AEP, all of our businesses on their computers looking at our real-time logging tool to see what is going on, right? And bam, no results found. Our logging tool wasn't able to support the volume of data that we were outputting during this period. And we were like, oh shoot, what do we do? Because real-time data is essential for a technology business. This digital space is not observable without data. All of these agents are home, right? We can't just pop our heads up from a cubicle and be like, hey, is everything working fine for you? Is anyone having problems, right? We need real-time data to understand if, like, our basic functions are working. Can our shopper get on our websites and see it? Can they submit the information? Are we dialing them when requested? Are we successfully routing calls to our agents? once they connect? Can agents submit the enrollments themselves, or are they having challenges with it, right? We operate within this distributed system, and that needs that real-time visibility, right? Let's just say one example, right? If we're in the dark, we can't adjust course. If we have this TV ad that shows up with Danny Glover that starred in, right, we can get this huge, unpredictable spike in demand, right? This TV ad played on an unknown schedule, happened at this random time in this state, boom, a huge spike in demand. Without the real-time logging tool, we can't prepare agents. We can't get more agents and drum up more agents onto the platform to meet that surge in demand. So when this happened, our senior director of data and engineering, Callum, thought, hey, let's replace it with our data lake, right? Okay, how do we do this? How do we get this done? So the data engineers, data scientists, and our managers go, okay, let's get this done. What do we need? We need to inspect the logging indexes to identify the key data sources that are powering the original sort of real-time dashboard. We need to cross-check this against what's available via our large catalog of connections in Starburst. We need to identify the data gaps that we are still missing and really set up these streaming events for those gaps and write them into S3. Then we connect all of that into Starburst and connect Tableau to Starburst, and voila, we were able to get a dashboard built really quickly, right? That has real-time data, and business outcomes was immense, right? We massively accelerated our time to insight. What could have taken days or weeks to actually fix this service and potentially causing inefficiencies, resulting in hundreds of thousands of dollars of lost revenue, took really 3 hours to replace. Some bonus outcomes is like we present this dashboard at our company's all hands that afternoon, right? And the dashboard is still used daily with tens of thousands of views and very low maintenance. And really brought in the new data with Starburst to really create the new visualizations in Tableau, which is much better than our original logging tool to make actionable insights. Tableau is much better at displaying some of this data than other tools. All right. So now we've gone through the crisis, got our line of sight back into our business. We get to our last case study, rocking recommendations. How do we really determine the right product for a customer? That's a difficult question. Some example data that we might be using to generate this recommended plan is here, like user-provided data, third-party data, proprietary data that's our own, right? And observe session data as they progress through the session. The amalgamation of all these different data points profile the customer with specific characteristics for us to recommend them, right? And Medicare is really complex, so our first recommendation is probably not going to be the best one. The first model is not going to be the best one for everyone. And we're going to iterate. And all of this is enabled by Starburst, right? We need to define the problem, understand the data, design the model, implement it, evaluate it, and continuously improve it. And do this rapidly to be able to really succeed. And this is especially important for the Medicare AEP, as we have majority of our Medicare business within that 7-week period. This is super high stakes. If a model is under-optimized in production, this leads to inefficiencies. A lot of customers may not get the best plan for them, and so they won't really buy the plan. And we'll be losing out on potential customers, which we've already paid marketing costs to acquire, and thus lower revenue. This is where Starburst came in. And it's a critical piece of this rapid development process. Here, we've abstracted away a lot of our complexity of setting up this process for our data scientists. So they can immediately ingest the data they need for initial model training with Starburst. Right? They can just pull from wherever they need. And then once we've iterated and picked the model we think is best, we can deploy that to our shadow environment, which is a sample of production data. And this data then will flow to the shadow audit chain through the kinesis pipes. Right. And this data will include things such as predictions, feature inputs, and other such information that on the run, a model invocation, it'll publish all that information out. And so this ensures in the shadow environment, this ensures some basic checks are passed, that models aren't failing due to missing data or inputs and stuff like that. And then this will give some confidence in, hey, this won't break production before deploying to production. Once that's been deployed, we can use the same process to log that production results in the audit chain, and then use that to train and improve the model, because we've already got all the feature inputs and predictions and everything being published. We can reuse that data to retrain the model on newer data continually, right? And an example would be, say, like, our third-party data sources don't always return data in time for our real-time predictions. So we can log that down to the audit chain. We can log when, how often we impute and stuff like that. And we can use that in the training to account for the flakier sort of input sources that we don't always get, right? What Starburst has really allowed us to do here is to simplify the access to this audit chain model and parse out the JSON within it dynamically when new models or data are deployed to it, so that it's very easy for the data scientists to continually analyze this with any new model deploys. And how's that work, right? How does that affect our business outcomes? With more robust modeling, to getting all these sources from all these different sources simply, we're able to monitor model production against a control group very easily. And initially, this black line is a percentage improvement in policy retention rates compared to the control group. We're using policy retention as a metric on whether or not recommendations were successful. We initially have better results with our initial model, but then integrated rapidly with all the new data. And then we iterated rapidly to make sure it goes up and to the right in improvements, which results in a better experience overall, as shoppers are happy with the plan, so they don't cancel or switch out of the policy. Agents are happy that the policies they sold are the best solutions for the shopper, and they'll get commissions on it because they haven't swapped. And the carrier is happy that the shopper just didn't cancel the plans, and so they have business. And our business gets more revenue out of this as well. So really a win-win-win across the board. And so in summary, Starburst enabled us to accelerate our time to insight, improve our conversion rates, and enable our robust modeling, allowing us to achieve better business outcomes by optimizing our agent licensure mix, to getting visibility back into our operations during critical moments, and to increase revenue by recommending better products to our shoppers. Before I end this, a huge shout out to our data science team for thinking and really taking all these tools and running with it and making really cool models and recommendations that we can really be proud about. And our data engineering team for really building out all these tools and supporting it going forward. Like a huge shout out to Starburst, this entire Starburst team for supporting us throughout this integration. What's next for Assurance and Starburst? We're really looking into DBT to really enable our scientists to build out our lakehouse so we can scale out with the business, create the metrics that the business wants, and really define that in a place that is centralized and really build out our lakehouse. Thank you for your time. I hope this was helpful. Have a great day.